In this video, we are going to talk about some special right triangles. Pardon me. So we're focusing on two specific kinds. The first kind I want you to think about are right triangles where both of the acute angles are 45 degrees. So if they're both 45 degrees, what do we know about the sides? Well, we know that they would have to be the same. So another way of classifying this is calling it an isosceles right triangle. And the reason I need you to keep that in mind is that if these are the same, then even though I'm not giving you the other leg of this right triangle, you know that this is 3. So what I want you to do is find the unknown side length. So go ahead and pause and do the Pythagorean theorem and find the hypotenuse. So if you paused it, then you did a squared plus b squared equals c squared. 9 plus 9, which is 18. And here I want you to keep it as a square root, a reduced simplified square root. So when you take the square root on both sides, simplify the square root of 18 to be 3 root 2. And if you need to, go back to the beginning of first semester to refresh how to simplify square roots. So this hypotenuse is 3 root 2. Now let's do the same thing over here. All right, so again, I don't know these, but I know that they're the same. So rather than calling this A and B, I'm going to call them both A and A. All right, so instead of doing a squared plus b squared equals c squared, I'm going to do a squared plus a squared equals 12 squared. So I can combine like terms, which would be 2a squared equals 144. I'm going to divide by the 2, which gives me 72. And then I'm going to square root. So again, keep this as a perfect square root, and then you get 6 root 2. So the reason I wanted you to do this is because we're going to be looking for patterns here. Now, I don't know if it's odd to you, but the square root of 2 is coming up quite a bit. So let's think about what's happening with this. So these special right triangles, we're going to be recognizing these patterns because it'll help us do problems more quickly. So rather than having to do the Pythagorean theorem every time, we can focus in on these particular ones because they do have patterns. And these properties will always be true for right triangles with these angles. So right now we're focusing on 45, 45, 90 triangles. And then later in the video, we'll look at 30, 60, 90 triangles. All right, the 45, 45, 90. So in that warm-up, we found that when the two legs were 3, the hypotenuse was 3 root 2. And I want to make sure you believe me when I say that this will work for any triangle. So I'm going to do this, instead of calling these 3, I'm going to call them n, like I have in this general triangle. So if I'm trying to find the hypotenuse, then I would do n squared plus n squared equals c squared. And just like before, we would combine our like terms and get 2n squared equals c squared. And then if I was trying to solve for c, I would take the square root. So here's what happens. The square and the square root on the n squared cancel out. So I just have n. But I don't have a square on the 2. Do you see that? So this does not have a square, but the n does. So this cancels with that, but I still have the square root of 2. So my c will always be n times the square root of 2. So whatever your legs are in a 45-45 triangle, the hypotenuse will be that number times the square root of 2. And that makes sense, right? Based on the Pythagorean theorem, and it makes sense to be multiplying these legs by something to make that larger hypotenuse. All right, so let's apply that. So let's say you're given a bunch of problems like this, where you know the leg of a triangle. So all we have to do is to find the hypotenuse. This is h for the hypotenuse, not for height. And then this is the side length, s. So all we have to do to find the hypotenuse is take the side length and multiply by the square root of 2. So I'm not doing the Pythagorean theorem every time. I'm just using this pattern. So in this one, this is a 45-45 because of that. So I know that the other leg is 10, and that this hypotenuse would just be 10 root 2. Done. Problem is finished. All right, easy, right? So again, over here, this is 45-45. So this other side has to be the square root of 6. Now this one might take a little bit of calculation, but y is just going to be my side length, which is square root of 6, times the square root of 2. So we know that that'll be the square root of 12. And then if we simplify that, remember that'll be 4 and 3. So if I simplify that down, that'll be 2 root 3. Now you may not like having to do the square roots by hand, but considering you don't have to do Pythagorean theorem, just consider it a trade. All right, and then 45-45 again, so this other side is 4 root 3. And then y is going to be that side, 4 root 3, times the square root of 2. Remember, the 4 does not get multiplied by anything underneath the square root. So the 4 stays 4. The two numbers underneath the square root get multiplied together, and that's root 6. Root 6 cannot be broken down, so our hypotenuse is simply 4 root 6. All right, easy enough, right? That pattern helps us a lot with time. Now going backwards, let's say I do give you the hypotenuse, and you have to find the side length or the leg. All right, so again, this is hypotenuse, and this is a side length. So if I'm going from a large side to a smaller leg, then it makes sense that I would divide by the square root of 2. All right, so here's how we can use that. I know it's 45, so I'm going to be taking my x and my y will be equal to 8 divided by the square root of 2. Now here, we typically won't leave the square root of 2 in the denominator. So when we talk about simplified square roots, you never want to leave a square root in the denominator. In order to get around that, we're going to multiply by 1. But the 1 that I'm multiplying by is going to be of this form. Now, where did I get that form? There's lots of forms of 1. I chose that because I want to cancel the square root in the denominator. So if I multiply it by itself, then it's squared and the square root cancels. So what I end up having is 8 times the square root of 2 in the numerator. In my denominator, I have the square root of 2 times square root of 2. You can think of it as square root of 4, which is 2, or you can think of it as the square roots canceling, which is 2. Either way, the square root in the denominator cancels out. The only other thing you'd have to do is simplify that fraction that's outside of the square root. So 8 divided by 2 is 4 root 2. Okay? And you might get quicker as you do these. Like on the other one where we had 12 was the hypotenuse, notice that it was 6 root 2. So when it's even, it's really nice because 8 divided by 2 is 4, and then we have root 2. So you might start seeing patterns like that. And if that was confusing, then go back and rewatch that, or you can ask me about that in class. So let's do another one. All right, we have 45, and I know the hypotenuse. So my x is going to be 12 divided by root 2. So how do I get rid of that? Multiply top and bottom by root 2. So I have 12 root 2 over 2. And now we reduce the 12 over 2. So x is going to be 6 root 2. So that's like the beginning problem. Do you notice how we were able to solve that just as fast, if not faster, than when we did Pythagorean theorem? Okay. And then one more. We don't have 45-45. Do you notice how they didn't? I was about to circle the 45 degrees, but they don't have that. However, they do have these tick marks, which means it's an isosceles. So then you know that this is a 45-45-90. So if we know the hypotenuse, then we're going to divide that by root 2. In this one, it's nice. The root 2's cancel. So my x is just going to be 6. All right. So that's a 45, 45, 90. Let's look at 30, 60, 90. Okay, same idea. We have these side lengths, and I want you to find the missing side. So pause the video, do the Pythagorean theorem, and let's see if we notice any patterns. Okay, so I have done my Pythagorean theorem. Let's look at the one on the left. You should have gotten that that other side length was 4 times the square root of 3. That was just straight Pythagorean theorem. Make sure you simplify the square root of 48. And then over here on the right-hand side, when you do Pythagorean theorem, I wanted to point out here that when you square 7 root 3, it's like you're squaring both of these things. So you're squaring the 7, which is 49, and you're squaring the square root, which cancels that, and you're just left with plain old 3. So 49 times 3 is where you're going to get 147. All right, so you should get that your other leg, your missing leg, is 7. So look at those numbers for a minute. See if you can find the pattern before I go to the next slide. All right, so before I show you what the actual pattern is, I want you to think about where this specific triangle is coming from. The 45-45, we care about that because it's an isosceles right triangle. The 30-60-90 comes from an equilateral triangle. So let's think about an equilateral triangle for a minute. All right, equilateral triangle, all the sides are the same, all the angles are the same. Specifically, they're all 60 degrees. Now, if I drop an altitude from one of the vertices, okay, that will also be a perpendicular bisector because of the nature of equilateral triangles, and we've proved that before in class. So what happens is when I drop that, it cuts that angle in half. So these angles are each 30 degrees. So this is actually where the 30, 60, 90 triangle comes from. And the reason that's important is, let's say that we knew that each of these side lengths of the equilateral triangle was, I don't know, 8. Okay, now when I drop that altitude, which is also a perpendicular bisector, a median, and so on, then I also know that this side gets bisected. So each of these will also be 4. So that relationship is very important. So when we have a 30, 60, 90 triangle, notice that the side that was the equilateral triangle side is the hypotenuse of the 30, 60, 90 triangle. Okay, so that's like our C. So it'd be like if our C was 8. And then the 4, the part that gets cut in half, is across from that 30-degree angle. Okay, so this is going to be 4. So anytime you do that, you're going to have that relationship that this smallest side in the triangle, the side across from the 30, is always half of that hypotenuse. So you could write it as, if this is C, and then this is half of C, or we could write it the opposite, because I don't like to use halves. I'd rather do the opposite. So I'm going to say if A is X, then the hypotenuse has to be twice as big. So either way, you could have said that C is X and A is half of X. But what I'm going to show you is if I use this in the Pythagorean theorem, then we will always get the same result for our B side. All right, so we're trying to figure out what B is. So we have A squared, which is X. We don't know what B squared. We're trying to come up with an expression for that. And then our C squared is 2X. Make sure you're doing 2X squared in parentheses. So this is going to be X squared plus B squared equals, square both of these. So that's 4X squared. And I'm going to subtract the X squared on both sides. So I have B squared is equal to, this will give me 3X squared. And now when I take the square root to solve for B, I have the same situation as we did with the 45, 45. The square and the square root are going to cancel, but notice that the 3 does not have a square on it. So I'm just going to have a plain old x that will not be underneath the square root, but then when I take the square root of 3, that's not squared, it just stays square root of 3. So my b is always going to be x times the square root of 3, and that is y. All right, so going back to the warm-up, let me flash back there for a minute. Notice that the side across from the 30, whatever that was, the hypotenuse was twice as big. This was 2 times 4. And that the side across from the 60 was that 4 times the root 3. Same thing over here. The side across from the 30 was 7. The hypotenuse was twice as big. And the other side was 7 times root 3. Okay, so having that pattern now, we're going to use it to help us find these in a right triangle. So now the advantage of this is we would not be able to solve for these sides of a triangle before, because we wouldn't have enough information to do Pythagorean theorem. So this pattern actually allows us to do problems that we would not be able to do before. So let's say in these problems, notice that we are given the side across from the 30-degree angle in all of these. All right, so if that's the case, then if you're okay with it, I'm going to call this the short side for S. I'm going to call the side across from the 60 L for long side, long leg, and then this will always be the hypotenuse for H. So if I'm given the short side and I'm trying to find H, then all I'm doing is doubling that. Okay, so the hypotenuse is 2 times the short side. And if I wanted to get the long side, or the long leg, I would just take my short side times the square root of 3. All right, so let's do that. So for over here, my y is my long leg, so I'm just going to take my 12 and multiply by the root 3. Done. And then for my x, which is the hypotenuse, I'm just going to double my short, which is 12 times 2, which is 24. All right, let's do the same thing over here. All right, I'm given 4 as my short side. Y is the long side, the long leg, I should say. So that's going to be 4 times the square root of 3. X is the hypotenuse, so that's going to be 4 times 2, which is 8. All right, and then in this last one, got to mix it up a little bit. So this is across from the 30, so that means we're given the short side. So y is going to be the short side times the square root of 3. So a little bit involved. 6 times root 3 is root 18. And then simplify that. That can be broken down into 9 and 2. So that's going to be 3 root 2. Okay. And then for my hypotenuse, x, we're just going to take our short leg and double it, multiply it by 2. That cannot be simplified, so just rewrite it as 2 root 6. All right, so then what do we do if we're not given the short side? Let's say we're given the hypotenuse. So in all of these, notice that the side that we're given is the hypotenuse. All right, so I always go back to the short leg first. So if you're not given the short leg, find the short leg first. Okay, so in order to find the short leg, I'm going to half that, just like we talked about earlier. So if I know the hypotenuse, to find the short leg, I'm going to take that hypotenuse and divide it by 2. Once I know that, then I can do the same thing we did to find the long leg. Okay, so in this one, x is the short side. Remember, I know that because that's across from the 30-degree angle. So I'm going to take 6 divided by 2. So I know x is 3. And then y is the long leg, so that's going to be my short leg times root 3. And we're done. All right, over here. First, pick out which is the short leg. Here's the 30-degree angle, there's the short leg. X is going to be half of my hypotenuse. So you can either, well, let's keep it as fractions. We'll just keep that as 5 root 2. I was going to write 2.5. And then y is going to be that short side times root 3. So 5 over 2 times root 3. So just put that root 3 in the numerator. And that's okay to leave it like that. You may not like how that looks, but you might want to start get used to that because you'll have lots of answers that look like that. And then on our last one, the variables are very consistent, so x is the short side. So we're going to take our hypotenuse and then divide it by 2. So here we can simplify that fraction on the outside, so that'll be 2 root 6. And then y is going to be our short side, which is 2 root 6 times the square root of 3. So that'll be 2 root 18. And remember, 18 can be simplified. So that'll be 2, still have 2. And I have 3 root 2. So that'll be 6 root 2 for our long leg. Okay. One more type. And that's what if we're given the long leg. All right, so in all of these, we are given the side across from the 60-degree angle. Again, the strategy is the same. If I'm not given the short leg, find the short leg first. So if I'm starting with the long leg, then I want to, instead of multiplying by 3, I need to divide by that root 3. So the short leg will be the long leg divided by root 3. And then once I have that, I will double that for the hypotenuse. So x is going to be 8 divided by root 3. Remember to rationalize that. Don't leave the square root in the denominator. Notice this time I'm not multiplying by root 2 over 2. I'm multiplying by root 3 over 3 because now I have root 3 in the denominator. So this will be 8 root 3 over 3. And that fraction does not reduce, so I'm just going to keep 8 root 3 over 3. So now for the y, which is the hypotenuse, I'm just going to double that. So I'm going to take 8 root 3 over 3 and multiply it by 2. So that's just going to be, remember, multiply the numbers outside. So that'll be 16 root 3 over 3. All right. This one, we've got root 2 is our long leg. So our short leg x is going to be root 2 divided by root 3. Make sure to rationalize. So that's going to be root 6 over 3, and that cannot reduce. It's tempting to reduce that to be 2 or the square root of 2 or something, but that's all it can do. The 3 is not underneath the square root, the 6 is. So that's your short leg. And then our y this time is the hypotenuse. So we're going to double this. We're going to take 2 times our short leg. And that cannot be reduced at all, so you just write it as one single fraction. All right, try this last one on your own. All right, so there are my answers for x and y. Please check that you got them correct. And if you didn't, pause it and look at my work.